Welcome to Science Store online classes.
Don't forget to like our video and subscribe our YouTube channel for all the updates.
Hello dear students and welcome to CET JEE classes of inverse trigonometric functions. As in the previous class we have discussed a few properties of inverse trigonometry. We will continue to understand a few more properties, okay, which are very important as far as competitive exams are concerned. The first property here, you have sine inverse of x plus or minus sine inverse y is equal to sine inverse of x into under root 1 minus y square plus or minus y into under root 1 minus x square. Here if you have plus, then you will have plus here. If you have minus, you will have minus here, and this property is valid only for this condition if x square plus y square is less than or equal to 1. So if it is greater than 1, then this is not valid at all. When the second one, cos inverse x minus or plus, okay, get the difference here, I'll explain. Minus or plus cos inverse y is equal to cos inverse of xy plus or minus under root 1 minus x square under root 1 minus y square. Okay, so note one point here. See, if you have minus here, then you will have plus here, right? So two properties are combined together and written in this way. So please understand to how to distinguish them. So if you have plus here, then you will have minus here. So when you write the property, you can write it separately, or if you are writing together, don't be confused with this. This is not plus or minus, minus or plus. Okay. The next property is 2 sine inverse x is equal to sine inverse of 2x under root 1 minus x square. You have proved this. How you have proved? So substitute x is equal to sine theta. So if you put x is equal to sine theta, this will be 1 minus sine square, which is cos square, under root will be cos, and you have to put x is equal to sine theta. 2 sine theta cos theta will be sine 2 theta. Sine inverse of sine 2 theta is 2 theta. Theta is sine inverse, so that is 2 sine inverse. Okay, so this is also you have proved. So 2 cos inverse x is equal to cos inverse of 2x square minus 1. So please note these properties. Alright, so you have worked examples in NCERT, okay, in your board syllabus. You have worked these examples. Now we will learn it as a property. We will use it in the problems. Okay, and now the fifth and sixth property you have learnt, but you have learnt only the first one. Okay, so what is tan inverse x plus tan inverse y? That is equal to tan inverse of x plus y divided by 1 minus xy. So if xy is less than or equal to 1, this xy, okay, so if x into y is less than or equal to 1, then this property holds. But what if xy is greater than 1? What if this is greater than 1? Then you will get negative or not? Okay, so you will get the fourth quadrant or not? You will get the fourth quadrant, see. Alright, so negative, minus, fourth quadrant. So you have to add pi, okay, so that it goes to second quadrant. It goes to second quadrant. See, if xy is greater than 1, then what is tan inverse x plus tan inverse y? Pi plus, okay, pi plus. All right, so I will explain this. Okay, so we'll take an example. The example is tan inverse half plus tan inverse 1 by 3. Okay, so tan inverse of half plus tan inverse of 1 by 3. Okay, so now what will happen here? You have to use one of these properties. Okay, so which property you will use? Do you use the first or the second? So for what you were using, you had only one property, so you used to use the first property. You would not care what happens to x and y, correct? Now you have to care in competitive exams. Okay, so they won't give you this problem which satisfies this condition itself. They may give an example which satisfies the second condition. So then you have to go for this formula. Let's understand clearly. Okay, now what is x into y? So x into y is half into 1 by 3, which is 1 by 6. Is it greater than 1? No. You are dividing 6, correct? From 1 you are dividing. You are dividing 1 into 6 parts. So it will be 1 out of 6 parts. So it is less than or equal to 1. Okay, strictly saying it is less than 1, correct? Okay, well, now we are getting xy is less than 1. So that means you have to use the first formula. So what is tan inverse half plus tan inverse 1 by 3? Tan inverse of x plus y. So what is x plus y? It is half plus 1 by 3 divided by 1 minus half into 1 by 3. So simplify this. Let's see what we get. So tan inverse of you take LCM is 6, so that is 3 plus 2, 5 by 6, and here it is 1 minus 1 by 6, so 1 minus 1 by 6 is also 5 by 6, but I'll write one more step. Okay, so this is tan inverse of 5 by 6 divided by 6 minus 1, 5 by 6, so that is 1 tan inverse of 1. Now what is tan inverse of 1? For what angle you get 1 in tan? For 45 degree. So 45 degree is here, correct? So that's in the first quadrant, 45 degree. So this is 0, 90, 180, correct? So 270 and this is again 360. Well, 45 degrees here in the first quadrant. So you are getting a first quadrant answer there. You are getting a first quadrant answer there. So which is true? Which is true, correct? All right. So now let us take one more example. So one more example is tan inverse half plus tan inverse 1 by 3, correct? That's the same thing, I'm sorry. So tan inverse 2 plus tan inverse 3, I'm sorry. Alright, so let's take this example. Now what do you have in place of x and y? You have 2 and 3. So what is xy? Both are greater than 0, correct? Okay, fine. So what is xy? xy is 2 into 3, which is 6. Now 6 is not greater than not less than 1, it is greater than 1. Okay, so if it is greater than 1, you must use this formula. Let's assume I don't know this formula, so I'll use this formula itself. Okay, so then let's see whether we get different answers or not. Okay, so what I'll do, I'll use the first formula itself because I have not learned this. Okay, so I don't know what about I don't know that there are two different conditions. Okay, so let's see, do we get the same answer? So tan inverse I'm using the first formula, so 2 plus 3 divided by 1 minus 2 into 3. So that is like tan inverse of 5 divided by 1 minus 6, that is also 5. So tan inverse of 5 divided by 5, which is tan inverse of 1, and that is equal to pi by 4, correct? So tan inverse half plus tan inverse 1 by 3, we got pi by 4. Now also we are getting pi by 4. So is it correct? Is it correct? If you are saying it is 1 second, 1 minus 6, that is minus, so minus, so this is minus pi by 4. So where is minus pi by 4? So minus pi by 4 is here, minus 45 degree in the fourth quadrant, minus 45. Now let's understand what is tan inverse 2. It is approximately 65 degree. Okay, and this is 70 degree. Alright, so 65 plus 70 will be 135 degree. So 135 degree is here. So this is 0, 90, and after 90 you have 45. So this total angle is 135 degree. Okay, so that's in the second quadrant. So that's in the second quadrant. So if you understand directly, we are getting 135, second quadrant answer. But after using the formula, we are getting minus pi by 4. That means this formula is wrong. Therefore, we must use this formula. Alright, so what we must do, we must just add pi plus. Okay, so when we add pi plus, what difference do you have? What difference do you have? You have tan inverse of minus 1, which is pi minus pi by 4, correct? Okay, so pi minus pi by 4. Now what is the answer we are getting? Now what is the answer we are getting? 4 pi minus pi. So 3 pi by 4. So 3 into 45 degree. So that is 135 degree, which is true. LHS and RHS, we are getting the same answer here. So that's why I am saying if xy is greater than 1, you cannot use the first formula here. You have to go for the second, that is pi plus tan inverse of xy. Well, so I hope that is clear. So you must use the second property and not the first property in case you have xy greater than 1. So if the product xy is less than or equal to 1, you can obviously use the first property. Well, let's continue with the next property. Well, the next property, property number 7, you have tan inverse x minus tan inverse y, just like the previous, tan inverse x minus y divided by 1 plus xy for every x greater than 0, y greater than 0. So here you don't have two branches here, so just one branch is enough. So just like the previous, if you have instead of plus, if you have minus, you will have minus here and plus here. Well, the next one, 2 tan inverse x. So how do you get these two? Just from the previous 5th and 6th property. Alright, so in place of y, if you put x, if y is equal to x, you will get tan inverse x plus tan inverse x, correct? So x into y, if it is less than or equal to 1, then it is straightforward answer, correct? So if x into y, see, understand, this is like tan inverse x plus tan inverse x. Are you understanding this? So you have to use tan inverse x plus tan inverse y formula. So there are two formulas for that. If x into x, x square is less than or equal to 1, then this answer tan inverse 2x by 1 minus x square. If x into x, x square is greater than 1, so this is comparable with this. Remember? Okay, so if xy is greater than 1, then pi plus, correct? So now x and y are same, so x into x, so it is x square. So if x square is greater than 1, then the formula is pi plus tan inverse of 2x by 1 minus x square. So once again you have two formulas for 2 tan inverse x depending on the conditions. Well, now coming to the next property, tan inverse x plus tan inverse y plus tan inverse z. So if you have three things, then tan inverse of x plus y plus z minus x y z divided by 1 minus xy plus yz plus zx. Well, now what will happen if you have 3 tan inverse x? What does it mean? Tan inverse x plus tan inverse x plus tan inverse x. So this will be x plus x plus x, which is 3x. So this is x into x into x, that is x cube, and 1 minus x square plus x square plus x square. So that will be 3x square. So if you remember this formula is very easy to get. Okay, so well, now 2 tan inverse x can also be written as sine inverse of 2x by 1 plus x square. Get the difference here, 1 minus, but here you have 1 plus, and 2 tan inverse x is equal to cos inverse of 1 minus x square divided by 1 plus x square. Well, so these are a few properties which you need to learn before we start the examples. So learn these properties without any mistakes. You will excel when you solve the examples. So next we will solve a few examples which are connected to these properties. Well, let us solve some examples using the already learnt properties. First, cos inverse 4 by 5 minus cos inverse 12 by 13. Okay, so here you have cos inverse x minus cos inverse y kind of property. Alright, so the options are 77 by 85, 63 by 65, 36 by 65 and 33 by 65. Well, I hope you remember the property. Okay, so if you don't remember, I will write that property again. So cos inverse x minus cos inverse y. So that is equal to cos inverse of x y. So if you have minus here, you will have plus here, under root 1 minus x square under root 1 minus y square. Well, so here you have cos, correct, of cos inverse 4 by 5 minus cos inverse of 12 by 13, correct. So I am using this property, so I will keep this cos as it is, nothing to change there. So this is cos inverse x minus cos inverse y, so I should write cos inverse of xy. So x and y must be multiplied and then plus under root 1 minus x square. So what is 4 by 5 square? I will write 16 by 25 under root 1 minus 12 by 13 whole square. So that is 144 by 169. Okay, so now this is like cos inverse of 4 into 12, 48 divided by 5 13s are 65 plus under root 25 minus 16, 9 by 25, and under root, what you get here is 169 minus 144. So that will be 25 divided by 169. Well, let's continue. I'll continue from here. Let's have the options on the board. Well, now this is cos inverse of 48 by 65 plus this is 3 by 5 into you have 5 by 13. Okay, so we are very close to the answer here. So cos inverse of, you have 48 by 65 plus 3 into 5, so 15 by 5 13 is 65. Well, so finally you add both the fractions here, and that's it, you have your answer. So this is cos inverse of 48 plus 15, 63 by 65. Okay, so cos of cos inverse, so that will be only 63 by 65. So that's a property, don't cancel out cos and cos inverse. So cos of cos inverse x is x only for the specified conditions, you know those conditions. Okay, so well, now this is 63 by 65, correct, so which is less than 1. So this x should be less than 1, then only we can write that. Now we can write it, so it belongs to minus 1 comma 1. Okay, so it is accepted, and the answer is the option B, 63 by 65. So I hope you understood the property and the application of it. Okay, so please learn that property, it's very useful. Otherwise, how do you solve usually? You convert this into tan inverse, you convert this into tan inverse, then use the property tan inverse x minus tan inverse y. That is also fine. Okay, it works well, but it takes some time, whereas this takes lesser time if you are good at multiplication and addition of the fractions. Well, let us continue with the next example. The next example applies the property sine inverse x plus sine inverse y, that is equal to sine inverse of x into 1 minus y square plus, so in sine inverse if you have plus, you will have plus here, so this is y into 1 minus x square, right? So that's the property we have learnt, so let us use it. So now sine inverse 2 root 2 by 3 plus sine inverse 1 by 3. So I should be writing x, that is 2 root 3. So I presume the space is not enough for me, so I'll write it here. Okay, so this is 2 root 2 by 3, which is x, and under root 1 minus 1 by 3 square, that is 1 by 9, plus y, that is 1 by 3, under root 1 minus x square, that is 2 root 2 square. What is 2 root 2 square? 2 square is 4, root 2 square is 2, 4 2 is 8, divided by 3 square is 9. Well, now what is left is only simplification, which can be done quickly depending on your skills. So this is 2 root 2 by 2, and under root 9 minus 1, 8 by 9, correct, plus 1 by 3, and 9 minus 8 is 1 by 9. Okay, so that is like sine inverse of 2 root 2 by 2. Now root 8 is also 2 root 2 divided by root 9 is 3. Okay, so I made a mistake while copying, so this is 3 plus 1 by 3 into square root of 1 is 1, square root of 9 is 3, so that is 1 by 3. Well, let me continue here. This is done and dusted. Okay, now this is equal to sine inverse of you have 2 into 2, that is 4, root 2 into root 2, that is 2, 4 2 is 8, divided by 3 3 is 9, plus 1 into 1, 3 into 3, 9. Okay, so what is it? This is sine inverse of 8 plus 1, 9 divided by 9, correct? If you take the LCM, common denominator, okay, so that is sine inverse of 1, which is 90 degree. So sine inverse of 1 is 90 degree, and hence the option B is the answer here. Well, this is about the property with the sine inverse x plus sine inverse y. The previous one was with cos inverse x minus cos inverse y. So the problems with tan inverse x plus tan inverse y are familiar to you, right? We'll continue to solve the examples. So thank you. Well, dear students, the next example, you have to find the value of tan inverse m by m plus 1 plus tan inverse of 1 by 2m plus 1. So this is a typical problem of tan inverse x plus tan inverse y. Okay, so well, let us use the formula. So what is the formula? Tan inverse of x plus y divided by 1 minus xy. So plus divided by 1 minus m by m plus 1 into 1 by 2m plus 1. So let me simplify this. So this is like m plus 1 into 2m plus 1 is the LCM, and here you have to multiply 2m plus 1. So that will be 2m square plus m, and you have to multiply m plus 1 here divided by. So this is the LCM. So m plus 1 into 2m plus 1 minus m into 1 whole divided by m plus 1 into 2m plus 1, whereas the denominator gets cancelled, right? Okay, so this is a typical problem. You don't have to worry too much about it. Do it systematically, you will surely get the right answer. Well, let me continue. So this is equal to tan inverse of you have 2m square plus m plus m, which is 2m plus 1 divided by, say, multiply this 2m square, is it not, and m, and then 1 plus m is 2m, and 1 into 1 is 1, and minus m. So well, so you cancel that. Now what remains? 2m square plus 2m plus 1, 2m square plus 2m plus 1, which is 1. So that means the answer is pi by 4. Well, so this is a 45 degree. It's a standard problem, typical problem, very easy problem. Just use the property that you have learnt already. Tan inverse x plus tan inverse y is equal to tan inverse of x plus y divided by 1 minus xy. Well, let us continue with the next problem. I will just explain this problem. If tan inverse 2 plus tan inverse 3 are two angles of a triangle, then the remaining angle is, you have a triangle there. So two angles are given to you, so you have to find the remaining angle. Now what is the total angle in a triangle? So total angle in a triangle is 180 degree, that is pi. So I will begin writing this. Okay, so answer for the fourth question. See, one is tan inverse 2, the other is tan inverse 3, and the third angle I do not know, so I will take it as C, and the total angle will be 180 degrees. So let us write it as pi. Now understand, tan inverse 2 plus tan inverse 3, so tan inverse x plus tan inverse y, but now here xy is 2 into 3, which is 6, which is greater than 1. So if xy is greater than 1, then which formula you must use? Pi plus tan inverse of x plus y divided by 1 minus xy, is it not? So this knowledge is very important. You just can't skip this pi. You have to write this pi plus tan inverse 2 plus 3 1 minus 2 into 3. Okay, so when you have x into y greater than 1, then pi plus tan inverse of x plus y divided by 1 minus xy is the formula. You don't use the other formula at all. You have to use this, otherwise you will not get the right answer. So that point is very important here. Well, so that brings us to C, right? So C is equal to, so this becomes minus tan inverse of 5 1 minus 6. So that is equal to minus tan inverse of 5 by minus 5. So that is minus tan inverse of minus 1. So minus tan inverse of minus 1 is minus tan inverse 1. So this becomes plus tan inverse 1, which is pi by 4. So the answer is pi by 4. The option C is the right answer. So the only point that you have to remember is this: you have to write pi plus tan inverse of x plus y by 1 minus xy. So that is a very important property. Okay, so that's it for today's class. Thank you for watching.
Don't forget to like our video and subscribe our YouTube channel for all the updates.